Okay, this is from Unit 6, Lesson 6, Distinguishing Between Two Types of Situations. And our focus question, how can you distinguish between the two forms of equations of p times x plus q is equal to r and p times the quantity of x plus q is equal to r? So what's the difference if we see a situation? How do we know which form of the equation to use? So let's look at our warm-up. Which one doesn't belong? Seeing structure. So if I'm looking at these, I'm trying to see something that's different between these. And I can see right away that this one here has parentheses and the other ones don't. Let's see if there's anything else. Oh, this one has the 9 equals, and all these are equals 9. This one's starting out with 9 equals. This one has a multiplication dot sign there, symbol. And I don't see any multiplication symbols in the other ones, but I do see some multiplication. But this one just has a symbol. Let's see, what else? That's all I can see. This one here has a 4 plus a 3x. And I don't see a 4 plus 3x on any of these other ones. So, I mean, I guess you could say there's something about each one of these that makes it different. Okay, 6.2. So if we were in class, we would have a set of cards we can sort, but I'm just going to go through and see how we could sort these equations into different categories. So the instructions say, your teacher will give you a set of cards that show equations. Sort the cards into two categories of your choosing. Be prepared to explain the meaning of your categories, then sort the cards into two categories in a different way. Be prepared to explain the meaning of your new categories. Well, I'm just going to do this one time to save time. So I need to decide two categories I'm going to sort these cards into. And just looking at the equations, I'm looking through them here, and I could see that some of them have parentheses again, and some of them don't. So that's the way I'm going to sort my categories. Parentheses. And no parentheses. So this one has parentheses. So does this one. So does that one. So does that one. This one doesn't. That one does. No. No. Oops. No. And no. Okay, so once I sort these, I notice another thing. These are all adding some number, and here the addition takes place inside the parentheses, and so interesting. Okay, so let's go on to 6.3. Even more situations, diagrams, and equations. So we have two stories here. Story 1, Lynn had 90 flyers to hang up around the school. She gave 12 flyers to each of 3 volunteers. Then she took the remaining flyers and divided them up equally between the 3 volunteers. Okay. Story number 2. Lynn had 90 flyers to hang up around the school. After giving the same number of flyers to each of the 3 volunteers, she had 12 left to hang up around the school. So looking at these two stories, I notice we have 90 in both of them as the total flyers, and we have 90 here. She gave out 12 flyers. She gave out 12 flyers here. There's a 12 here, and there's a 12, and then we have 12s here. Then we had, so how am I going to decide which one goes with which? Because there's 12s in both of these. There's 90 total in both. So let's look at the stories themselves and see what kind of picture that it tells. So the first one says, she gave 12 flyers to each of 3 volunteers. So which one has that? Well, this one has 12 to 1, or it just has 112 in here. Here she has 12 in 3 different places, so I'm thinking that might be it. Let's finish. She gave 12 flyers to each of 3 volunteers. Then she took the remaining flyers and divided them up equally between the 3 volunteers. So yeah, so if Y was the remaining flyers, and she gave each of the 3 volunteers the same amount, it looks like that might work. So that must mean that story 2 goes with A. So story 1 is B. Story 2 must be A. So let's see how that looks. Lynn had 90 flyers to hang up around the school. After giving the same number of flyers to each of 3 volunteers, so if she gave the same number to each volunteer, this X here would be that. We don't know how many she gave, right? She had 12 left to hang up by herself. So this must represent the 12 that she had to hang up by herself. So it looks like that story 2 would go with A, and story 1 would go with B. So number 1, here's our questions now. Which diagram goes with which story? Be prepared to explain your reasoning. We did that. In each diagram, what part of the story does the variable represent? Well, if we look at story 2 in this, she gave the same number of flyers to each volunteer. She gave the same number of flyers to each volunteer. So that's what that represents, right? How many flyers she gave to each volunteer. She gave this volunteer some, this volunteer some, and this volunteer some. And then she had the 12. She had the 12 to hang up by herself. So here the variable represents the same number of flyers to each of the 3 volunteers, and the 12 represents the amount she had to hang up by herself. So let's look at this one. So let's look at the variable again. The variable here is Y. She gave 12 flyers to each of the 3 volunteers. That's not a variable. We know the amount she gave. Then she took the remaining flyers and divided them up equally. So these are the remaining flyers that she gave to each of the volunteers after she gave them each 12. So let's write an equation for this one. Let's write an equation for A and an equation for B. All right, so we had this one equals B, this one is A. So the equation for A, so we have 1, 2, 3 x's, and then an additional 12 for a total of 90. So we have 3 x's plus an additional 12, which is equal to 90. So that makes sense, right? 3 x's plus 12 is 90. In this one, our 90 is equal to y plus 12 plus y plus 12 plus y plus 12. So we have 3 equal parts of y plus 12. So I'm just going to take one of these and multiply it by 3. So 3 times y plus 12 is equal to 90. So let's find the variables. So we worked on solving both of these types already. So 3x plus 12 is equal to 90. So if we take away that 12 from the 90, we're left with 3x's. So if we take away the 12 from the 90, we're left with just the 3x's. So 90 minus 12 is 78. So those 3x's here are 78. And since they're in equal parts, and there's 3 of them, we're going to divide the 78 by 3, which will give us what 1x is. So we're going to divide the 78 by 3, and that will tell us what 1x is equal to. 78 divided by 3 is 26. So that means that the number of flyers she gave to each of the 3 volunteers was 26. So this volunteer had 26, this one had 26, this one had 26, and then she had the 12 for herself. Okay, let's look at B. How are we going to solve B? B is 3 times the quantity of y plus 12 is equal to 90. Okay. So if I take this 90, right, this is 90, and this is 90 here, right? This is equal to 90. If I take that 90 and divide it into 3 equal parts, if I take that 90 and divide it into 3 equal parts, that means that one of those parts is equal to y plus 12. So I'm going to take the 90 and divide it into 3 equal parts. And that tells me that one of those parts is equal to 30. Y plus 12 is equal to 30. So what number plus 12 is equal to 30? I can do that by doing some subtraction here. So y is equal to 30 minus 12, which is 18. So y is equal to 18. So in story 1, she gave each person 12 flyers, and then the remaining flyers dividing them up equally, so she gave each one 18. So this person had 18 plus 12, this person had 18 plus 12, this person had 18 plus 12, for a total of 90 flyers altogether. Okay, let's go to our notes. So what are some similarities and differences between the two forms of equations we have seen, and how do we know which one to use? So if we look at our two equations, 3x plus 12 is equal to 90, and 3 times the quantity of y plus 12 is equal to 90, we can see that this one, and if you remember the tape diagram, we had 3 equal parts plus a little extra added. And on this one, we had just 3 equal parts, right? The tape diagram was divided into 3 equal parts, and inside each of those parts was a sum of some numbers for a total of 90. So what are some similarities and differences? Well, they all have a 3, a 12, and a 90, right? 3, 12, 90. They both have variables. And this one's multiplying here, and this one is multiplying here. They both have some addition. This is adding, and this has adding. So the main differences here are this 90 here, in this case, is a sum, right? We're adding this term here to this term here to get 90. And this one, we're multiplying two terms. This term here, 3, times this term here, 2. Since this is in parentheses, we're grouping this together. We're multiplying to get 90. This one has 3 equal groups. This one also has 3 equal groups, but we're adding a little extra. So that's the main differences when you look at your problems and maybe you want to think about setting up a tape diagram or an equation. Is the tape diagram going to consist of only equal groups, or is the tape diagram going to consist of some equal groups plus a little more? So that's something you want to think about when you're writing and solving these equations when you're presented with some situation.